Hi, today we're gonna do this question which says find the amount of compression of the spring if the ball does free fall from 4 meter and compresses the spring. So we got a ball right here. I'm gonna draw the same ball. So 3 kilogram. So this ball comes down from, this is 4 meter. So from 4 meter height, and then it lands here and compresses the spring by this much height, which is x. So we're trying to find by how much, what is the value of x, by how much is the spring compressed. So I hope you got the idea. So let's go on and solve the problem. So solve for x. What's given is we got mass, which is written as m, 3 kilogram right here, and we got height 4 meter right here, and we got a constant called gravity, which is always the same amount, and for the sake of easier calculation we're gonna use 10 meter per second square. The actual value is about 9.81 meter per second square. Okay, now we're gonna solution. So solution. So we're gonna use the law of conservation of energy, which says energy is neither created nor destroyed. It only transfers from one form of energy to another form of energy. Okay, so from which form of energy into which form of energy? We're gonna use. Okay, now the ball, when it's 4 meter high, it has gravitational potential energy. So from the gravitational potential energy, that energy transferred into the spring, the spring potential energy. So the spring potential energy. So like I said, the energy is not lost. It only transferred in the entire universe. That's how things work. So from one form of energy, it transfers to another form of energy, but it's never lost or destroyed. Therefore, and each form of energy has its own formula. So the gravitational potential energy has a formula of mass times gravity times height, mgh. That energy transferred into the spring potential energy. So the spring potential energy is half kx squared. So what's k? K is the spring's constant value. Each spring has its own constant value, and k is, it's like the stiffness of the spring. You know, if the spring is very hard to compress or to pull, then it must have big stiffness or some kind of force. So that stiffness, it's always constant for each spring kind, and for this case we have k as right here 1200 Newton per meter. So Newton per meter means per each meter it has 1200 force, you know, pulling you against. So that's what k is. Therefore, now we know the formula. Now we can just plug everything. So that energy, if that energy, all of that energy transferred to the potential energy, we can change this to mgh is equals to half kx squared. So now we can solve for x. So x squared is equals to, so I'm just gonna divide by half x by half k, I mean, so it will be mgh divided by half k. So I just brought this half k into the other side, so this will be like 2 mgh divided by k. So therefore x by itself is equals to the square root of 2 mgh divided by k. Now if we plug everything, we'll get, so 2 times what is mass is 3 times g is 10 and height is 4. All that divided by k is 1200. If you use calculator or something, you will get about 0.45 meter. So this is how much the spring got compressed. So x, therefore we'll get x is equals to 0.45 meter. Thank you for watching.